Okay, so I'm going to look at the Group 7 elements section this time. First up is question 1. The elements in Group 7 of the periodic table are known as the halogens. So we're looking at fluorine, chlorine, bromine, iodine, and astatine down at the bottom. And it's asking us to tick which of the following statements is correct in the first instance. So the four statements are all discussing, in the first instance, whether or not they're non-metals or metals. Now, we know that Group 7 is on the right-hand side of the periodic table, and they are non-metals. So we can immediately discount two of the sentences in that they are not metallic. So we can get rid of statements 2 and 4. The question then comes from whether or not we know they are existing as single atoms or as molecules of two atoms. Now, we know from balancing equations that whenever we have a halogen in an equation and we know we need to balance an equation, we have to first of all ensure that we've got Cl2, for example, or Br2. So we know that these are molecules. These are diatomic molecules. And so the correct answer is the third one, where they exist as molecules of two atoms, and therefore we know it is not a singular atom situation, and obviously it wasn't the metals, as we'd already discussed. So what we have to do now then is compare the chemical reactivity of chlorine and bromine. Now, the first issue is we can discount anything to do with numbers of electrons or anything like that, because obviously they're both in group 7, and so they both need to gain one electron. So if we think about the way in which they do that, the nucleus is in the middle with the positive nucleus, where all the protons are, and the electron which is going to be accepted is going into the outer shell of that atom. So the electron is going to be accepted into the outer shell of the atom to create the ion. The strength or the power at which that happens is determined by the strength of the nuclear attraction between the protons in the nucleus and the outer electron energy level that that electron is going to go into. And the key thing here is the size. Basically, the bigger the atom is, the further away that electron is from the nucleus, and so the less strongly it is pulled in. There are, within an atom, complete shells between the nucleus and the outer shell of the electron. So the further away the electron is, it's less strongly held or less strongly pulled in by the nucleus, and so the larger the atom, the less reactive a group 7 atom happens to be. And in this situation, chlorine is the smaller of the atoms. That is a smaller atom. Bromine is a bigger atom, and so the distance between the central nucleus and the outer electron in bromine is bigger, and therefore the electron is going to be pulled in a lot better into the smaller chlorine than it is the larger bromine. So bromine is the least reactive. And in fact, as we go down group 7, the elements become less reactive as we go down group 7. Group 1, as we know, is the other way around. Okay, so question 1.3. Halogens can react with other elements to form molecular compounds. Of the following elements, suggest which one might form a molecular compound with chlorine. We can only tick one of the boxes. Now, we know that group 7 elements will also form ionic compounds. These are not molecular compounds. And ionic compounds are formed when we have a non-metal, in this case the halogen, reacting with a metal, and so we can immediately discount all of the metals. Calcium is group 2 metal, chromium is a transition metal, sodium is a group 1 metal, and so the only one which remains is phosphorus, which is a group 5 non-metal.